Here, I want to briefly talk about the grading of P4 because many of you asked questions on Piazza, and I want to answer some of you here. And the first question and the most popular question is, what kind of models do I consider trivial? And I will go through the examples that I gave, and then I'll tell you in comparison what kind of models are considered non-trivial. So the first one is actually the hardest one to implement, especially if you want to implement nonlinear least squares. However, I'm allowing you to use packages. So if you want to use a package like the nonlinear least square package in R, then you only need to specify the curve that you want to fit, and you need to specify which parameters you are fitting. Then it does the job automatically for you. So there won't be a lot of work if you don't want to program this from scratch. In R, I remember there are some convergence issues, so you do need to tune your learning rate and stuff. But in general, it's not a very difficult task if you use a package. So that's the first example. And the second one may sound a bit complicated, but I'm not specifying which parameters you need to use for the normal distribution. So I think the standard parameterization is mu, sigma, and beta. So they are the mean, variance, and scale parameter. So it may be difficult to compute the scale parameter, but as I said, you don't need to use that parameter. For example, what you can do is just compute for each time series, you just compute the mean, compute the variance, and maybe compute the third moment. So what I mean by third moment is just the sum of cube of each data. You can just do the cube, or you can do cube subtract the mean. Then I think it's called the symmetry. But in any case, you don't need the specific parameters that are on the Wikipedia page. But if you do want those three parameters, it's just solving three equations. So they are called the three moment equations. So basically, you compute the moments from the data, and you match it with the moment, the theoretical moment, as a function of the parameters, and you just solve the parameters. You need three equations to solve for three parameters. And if you have taken a statistics course that involves this, you know what I'm talking about. If not, as I said, you can just compute the mean, variance, and the third moment or symmetry of your time series. So that's the second one. The third one is the simplest one. It's just counting the number of days. So I would consider that one is the least amount of work you should do for the model to be considered non-trivial. So if you are just using a specific data on a specific day, then they are considered trivial. So for example, in the TA solution, they are just copying, say, three columns from the data set, and basically those models are not great. Okay, and the next thing I want to talk about is the format I want you to enter the answers to these questions. So the first two is just two time series, and there's nothing to talk about. And 4 is an important one, but you are just entering your data sets so that I can compare my clustering with your clustering. I think for the other ones, let me load the TA solution so that we can take a look. So one of them is graded incorrectly, but I'll talk about that later. So for 4, I'm expecting more than 100 lines, and each line contains at least 3 numbers, so something like this. And the question 5, I'm expecting you to specify the index of the cluster for each data. So the ordering should be consistent with the instances, the order of the instances you entered in question 4. And these numbers should be between 0 and 7. So why I have 7 is because there should be 8 clusters. So it depends on your ID. But in any case, here it should be from 0 to 7. So you have 1, 0, and 1, 1, and 1, 2. So it's not a great clustering. It means most of the countries are clustered in the same cluster, and there are a few that are like very far from the other points. So from the clustering, you can see how well you made the parameters, kind of. So when I go back and manually look at Q3, I will look at the clustering. If it looks like this, I will check what happens, basically. And the same thing happens with this complete linkage version. So when I grade, because there can be permutations. So for example, you can label cluster 7 as 0 and label cluster 0 as 7. So I'm not really grading exactly what you enter. I'm just saying how close your cluster is to my cluster. Not your cluster, your clustering is to my clustering. And the way I measure this is something called the rand index. And if you're interested in this, you can take a look at the Wikipedia page. So the one I use is the adjusted rand index. So it basically measures how close two clusterings are. So it takes care of the fact that we are labeling the clusters differently. So if I'm labeling two clusters as 0 and 7, and you are doing it as 7 and 0, then it does not matter. The adjusted rand index is symmetric in the way that no matter what kind of permutation you do, the rand index between the exact same clustering with different indices, with different indexing, will be exactly 1. And if two clusterings are not exactly the same, but they are close, then it will be something slightly less than 1. So what I'm grading is, as long as it's above 0.95, I'm okay with it. You'll get full mark. If it's less than 0.5, it means your clustering is very different from mine. So you will lose some points. Because we're using different tie-breaking rules, so I do expect they are slightly different, but not very different. So for Q7, I know that if you start from different centers, then of course you'll converge to different local minima. So I cannot grade it by comparing my local minima with your local minima. So here what I'm doing is I'm taking your cluster center as the initial clusters, initial cluster centers, and then I just run the algorithm, because what you are doing here is you should stop at the local minimum. So if I start from the local minimum, it should stay at the local minimum, so it should not move. So if I start from your cluster centers, it would stay at your clustering. So I'm just comparing the result of running k-means, starting from your cluster centers to your clustering here. If they are close, then I'll give you full mark. And similarly here. Here, I just compute the center of these clusterings. So they should be consistent. So here, the cluster center should be just the center of these 7 clusters. And question 9 is the question I want to talk about. So at the beginning, when the TA sent me the solutions, I didn't tell them to use the sum of square distances. And here I added a note that I want the sum of square distances. So the Euclidean distance is the square root of the sum of square of each individual element. If you square it, then it means the same as not taking the square root. So you just sum the square without taking the square root. And if you sum everything up, then you can get the total distortion. So I actually, if you use inspect and look at the console, then you can see a number. That number is the total distortion computed given your clustering. So if you copy this and if you paste it here, and here it's graded as 0. So if you click grade again, it should give you 5.